Hello, good evening all of you. Hopefully you all are doing great. Now today our topic is geometrical isomerism. It is continuity in the series of isomerism. We are going to study geometrical isomerism. We already know what is the meaning of word isomerism. Iso means same, merism means unit, same unit, isomer is same unit. Now what is the word geometry means? The word geometry means, word geometry comes from earth measurement. Geo means earth, metry means measurement. The earth measurement is known as geometry. And geometrical isomerism means isomerism related to measurements. Now first of all, what is the definition of geometrical isomerism? Geometrical isomer are defined as, they are stereoisomer. First, they must be stereoisomer. Second, they must be restricted rotation. And third, areal distance must be different. L1 is not equal to L2. Now first of all, I will explain you one by one what is these words mean. How to identify whether two isomer are stereoisomer or not. In order to check two isomer are stereoisomer or not, what you have to do, they must have same IUPAC nomenclature. Exclude RS configuration EZ. If we exclude RS EZ, then their IUPAC nomenclature will be same. Second is restricted rotation. Now restricted rotation means if there is a C double bond C, means there is a pi bond, or if there is a ring, there will be restricted rotation. Now let me show you some models regarding restricted rotation. The model which is in my hand, it is a trans 2-butene. It is a trans 2-butene and this is a pi bond. Now you can see easily, in case of pi bond, we cannot freely rotate. This pi bond cannot free rotation. The free rotation is not possible. That's why we call this pi bond as a restricted rotation. Got it? Whenever there is a pi bond, there may be double bond, triple bond, rotation will be restricted. Second type of restricted rotation will be in ring. Now you can see this 6-member ring and all this carbon-carbon bond are there. I cannot rotate this because if I rotate, bond will break. Free rotation is not possible. If there is no ring, suppose there is no ring and no pi bond, then rotation will be free. So when will be the free rotation? Absence of pi bond, absence of ring. When will be the restricted rotation? When will be the restricted rotation? If there is a ring, restricted rotation. If there is a pi bond, rotation will be restricted. Got it? Now let us take some basic example. First of all, I will take some basic example to explain this. So you have to write down the geometrical isomer are stereoisomer, restricted rotation and different areal distance. So first of all, write down in your class notes. Pause the video and write. Now let me explain one basic example. This is our 2-butene. If I number the carbon, this is second and second carbon means 2-butene. This is also 2-butene. Got it? In case of 2-butene, first of all, in order to check stereoisomer or not, what is the IUPAC name of this? Excluding Cis-Trans EZ, the IUPAC nomenclature is 2-butene or but2ene. Means they are stereoisomer. Got it? Now second one, rotation is restricted or not? In above example, rotation is restricted. Yes, restricted, yes, restricted. Why rotation is restricted? Because of this pi bond. And the third condition is areal distance. Now how to check this areal distance? If methyl is there, the distance between methyl is L1 and this methyl distance is L2. Then what is the relation between L1 and L2? Now in order to find L1 and L2, are they equal? If they are equal, then it is not a geometrical isomer. In this case, it is not equal. Got it? Since they are not equal, this means all three conditions are satisfying. They are stereoisomer, restricted rotation, and different areal distance. Now, if methyl is on same side, we call it as cis-butene. Methyl opposite side, we call this alkene as a trans-2-butene. What is the meaning of cis? Same side. What is the meaning of trans? Opposite side. So first of all, write down this example. Now let me explain this cis-trans by this model. This molecular model has cis-butene. If you watch closely, you will find there are 4 carbon, 1, 2, 3, 4. Black represent carbon, white represent hydrogen. White is hydrogen and black is carbon. Got it? And this rotation is restricted. So this is our cis-2-butene. Now if I ask you to draw trans-2-butene, what you have to do? Across this restricted rotation, our aim is to draw trans. Across this restricted rotation means across this pi bond. I will break these 2 valencies, then I will interchange and draw. Now this geometry is known as trans-2-butene. This model represents this trans-2-butene. Got it? Whenever you have to draw cis to trans, what you have to do? You restricted rotation, cut the restricted rotation bond, interchange, and then paste it. Now I will show you how to convert trans into cis. Same method. This is trans. I will break these 2 valencies. Then I will redraw. This becomes cis. Got it? Now write down this. Geometrical isomerism is exhibited by a wide variety of compounds, and they may be classified into 3 groups. Geometrical isomerism exhibited by a wide variety of compound and they classified into 3 categories. First, compound containing a double bond. The double bond can be C double bond C, it can be C double bond N, it can be N double bond N. Pi bond can between be like atom or pi bond can between be heteroatom. Got it? Second, compound containing cyclic structure. There may be homocyclic ring, just like this. There may be heterocyclic ring. Hetero means ring consists of atom other than carbon. This is heterocyclic ring because carbon is replaced by oxygen. So means cyclic structure must be there. Third, compound having exhibit geometrical isomer due to restricted rotation about a single bond. This is very rare example. I will explain this rare example at the end of the isomerism. There are some examples in which there are 3 rings are there, and because of bulky group there is a restricted rotation. I will take this example at the end of the geometrical isomer. And bicyclo compound. This is our bicyclo compound. They can also show geometrical isomerism. First of all, write down this. Pause the video and write in your class notes. You can also watch the animation of geometrical isomerism, which I already given in the description. Link is given in the description. You can watch exactly the 3D models, means animation of GI. Now let us consider these 2 examples. They are not geometrical isomer. GI means geometrical isomer. They are not geometrical isomer. Why? Because of free rotation. So due to free rotation, they are not geometrical isomer. They can be conformer. So which condition they are violating? They are violating the second condition, the rotation is restricted. Now in this example, they are stereoisomer. Yes, they are stereoisomer because of 3-hexene, same IUPAC nomenclature. Rotation is restricted. Yes, because of pi bond. Rotation restricted. Yes, because of pi bond. And third condition is areal distance. Just make a circle on the remaining group. The distance is L1 and distance is L2. What is the relation between L1 and L2? L1 is not equal to L2. So are they geometrical isomer? Yes, they are geometrical isomers. Pause the video and write this example. Similarly, we can draw one more geometrical isomer. If I ask you whether it is a cis or trans, cis means same side. There will be a lone pair, they are same side, this means it is a cis isomer. Now, if I want to convert into trans isomer, what I have to do? Across restricted rotation, I have to interchange these two valencies. In order to interchange these two valencies, rotation will be restricted and it is our transform. Got it? First one is cis, second is our trans. In case of cyclic, it is a 6-member ring. Suppose this is one of the isomer. This is our cis because of same side and this bond is rotation is restricted. Now, if I have to draw trans, what I have to do? I have to interchange this pair of group. And this is our trans isomer. Got it? Now, if I told you, if I ask you to draw geometrical isomer of this propene, can you draw geometrical isomer of propene? This alkene will not show geometrical isomerism. Why it will not show geometrical isomerism? Now, what I have to do, if I draw another isomer, if I cut these valencies, I will interchange and paste, what you will get? You will get identical compound. If I change this as methyl, I will get identical. This means if there is a like group on same carbon, means if there is a 2 like group on same carbon, it will not show JEE. Got it? To like group on same carbon, it will not show JEE. Similarly, I can also point to remember, you should write in your notes, terminal alkene will not show JEE. Why terminal alkene will not show JEE? Because if there is a terminal alkene, this means it is a like group. For example, this is 1 butene. It will not show JEE. Because of 2 like group, we get identical. For example, 1 hexene. It will not show JEE. Or we can say that if there is a like group on same carbon, for example, 2 phenyl are there, it will show JEE or not? It will not show JEE. So write these 2 statements in your notes. 2 like group on same carbon across restricted rotation. Same carbon, which carbon? The rotation is restricted. And terminal alkene will not show JEE. Why they are not showing JEE? Because on interchanging, we get identical molecule. Now, if I ask you, this alkyne will show JEE or not? In case of this alkyne, it will not show JEE because it is a monovalent. If there is only one valence is there, if I cut and paste, what I will get? I will get the same isomer. This means the monovalent will not show geometrical isomerism. Now, how many carbon needed by any molecule to show JEE? JEE means geometrical isomerism. how many carbon needed by any atom, any molecule to show GI? What is your answer? Minimum number of carbon needed by any molecule to show GI. How many carbon means minimum number of carbon? What is your answer? Answer is 0. Now how it is 0? Because there may be an atom other than carbon. I already took one example of nitrogen. And in inorganic chemistry, when we learn, you say coordination compound, they can also show geometrical isomerism. This means carbon is not necessary to show geometrical isomerism. So write this statement, carbon is not necessary to show geometrical isomerism. Now if I change this question and if I ask you, how many carbon needed by alkene to show GI? Same question, minimum number of carbon. Minimum carbon needed by alkene to show GI. What is your answer? Minimum carbon needed by alkene to show GI. And which is the lowest alkene which can show GI? The answer is 4. Minimum 4 carbon is needed by alkene to show GI, or we can say that the lowest alkene which can show GI is 2-butene. Now you have some doubt in your mind, why we are not taking this chloro, bromo? This is not an alkene, this is unsaturated halide. Whenever in the question it was given alkene, means what you have to take? You have to take CnH2n. You cannot take polyfunctional groups. Got it? Now in this case, this is unsaturated halide, it will not show GI. Similarly, you cannot use isotope. The isotope is used for kinetic purpose. The role of deuterium, the deuterium is to check the rate of reaction. So if I ask you to draw alkene, this means you have to draw CnH2n. Got it? Pause video and write these examples. Yeah. Now draw these examples. You have to draw geometrical isomers. One of the isomer is given, it may be cis or trans, you have to draw another isomer. Pause the video and try these examples. First of all, write down the question, pause the video. Don't see screen after that, just try in your class notes. Now, what is the answer? In first example, this is our cis alkene. It is sp2 atom. This means hydrogen must be at 120 degree. Now, I will break this bond and interchange, means it will convert into trans. Again, this is our trans. It will convert into cis. It is our cis. You can do interchange as either pair, either on right hand side, either on left hand side, it doesn't matter. They give same isomer. In example D, this is our cis. I will break this bond. This is our trans. Again, this is our cis. Rotation is restricted. This is our trans. In F, again it is a cis. This is our trans. Check your answer with my answer. Probably your all answers are correct. How many answers are correct? Just write in comment box. Similarly, you have to draw geometrical isomer of this. This is our cis. This ring is restricted rotation. Now, I will interchange Cl and H. This means it will convert into trans. The wedge represent above the plane. So, there will be a valency below the plane. Dash represent, dash means hydrogen means below the plane of the ring. This is our cis. How to draw trans? Wedge above the plane, dash below the plane. And what about I? GI is not possible because it is a monovalent. In monovalent, GI is not possible. Check your answer. Now, one more thing is there. This is our cis isomer, cis 1,2-dichloroethene. This is our trans isomer, trans 1,2-dichloroethene. If you see boiling point, the boiling point of cis is less, trans is more. Boiling point basically depend upon the, I think boiling point of cis is more, correct. Cis must be more, boiling point of trans must be less. Because if we check simply dipole, in this case, the vector will be in this type. In this case, they are cancelled out. This means what I have to explain, I want to explain you that cis and trans has different physical and chemical properties. Because of different dipole, their boiling point are different, their stability are different. Now, what you have to write? Geometrical isomer have different physical and chemical properties. Geometrical isomer have different physical and chemical properties. These are few examples. Geometrical isomerism, a stereochemistry in alicyclic compound. Alicyclic means open chain. This is our cis. This is our trans. Again, this is our cis. And this is our trans. Just write down this example in your notes. Now, we can explain the different physical and chemical property of this. Cis form is our maleic acid. Remember this name of dicarbonic acid, and trans is known as fumaric acid. As I already explained you that the geometrical isomer have different physical and chemical properties. You can see that boiling point is 130 and 286. Boiling point of trans is always greater than cis. How to explain this, I will explain you later on. First of all, remember the boiling point of trans is always greater than cis. Now, since they have different dipole, therefore boiling point is also different. So just write down these data and remember these two acids. Cis is maleic and trans is fumaric. And we will understand this, we will learn this in, study this in our reaction mechanism. If you heat this, if you heat cis, water will eliminate and it will convert into anhydride. Whenever vicinal dicarboxylic acid, what is the meaning of vicinal? Vicinal means acid on adjacent carbon. Whenever you will heat vicinal, on vicinal dicarboxylic acid on heating give anhydride. What is this? This is one more example, citraconic acid. If I replace this methyl by H, it is known as maleic acid. If I replace H by methyl, it is known as citraconic acid. It is our cis isomer and trans is our mesoconic acid. Although they are not very famous, I just took one example. I find the name very interesting. That's why I took two examples. Now, that's all for today. Today, I explain you what is the definition of geometrical isomerism. And in this lecture, we also learn how to draw geometrical isomerism and which compound will show geometrical isomerism. We will continue with this geometrical isomerism. Please spread the word among your friends that I am teaching in YouTube. They can take the benefit of my teaching through YouTube. Thank you. Jai Hind, Jai Bharat.